All right, so the objective of this lesson is to understand airplane weight and balance. Key points is performance, calculating weight and balance, adding, removing, and shifting weight. So if you look in the rest of the folder in weight and balance, you'll different calculations. I go over how to do it. So depending on time, we may just leave that for those individual lessons. Terms, weight and flight performance, weight and balance control, determining weight and balance. So that means, like, how does weight and balance affect how an airplane handles? And just determining what that weight and balance is. So without further ado, what weight and balance is basically balancing the airplane within approved limits. So think about balancing a seesaw. When you're real little, playing on the school ground, you had a seesaw, and you had a kid on one side and another kid on the other, and you may have practiced balancing that seesaw by putting the heavier kid closer in, and the skinnier kid on further out to change the moments of the seesaw. So basically the same thing for an airplane. We have a center of gravity, and that center of gravity is where we try to be sure and stay within those limits. All right. Why pilots need to keep weight within a safe limits and balance the loads carried to maintain control of the airplane. If you have weight too far aft, too much weight too far aft, you may not be able to recover from a stall. And if you have too much weight forward, you may not be able to get the nose up if you install the airplane. So key terms. Reference datum, or RD, is an imaginary vertical plane from which all horizontal distances are measured for balance purposes. So when we say arm, we'll get that term in a moment. When you hear the word arm, it's in reference to that reference datum. It could be located anywhere along the airplane. It could be out in front of the airplane. It could be at the firewall. It could be at the nose cone. It really is specific to the aircraft. A station is a location on the airplane fuselage, usually given in terms of distance from the reference datum. The arm, as I've already mentioned, is the horizontal distance, usually in inches, from the reference datum to the center of gravity of an item. Arms ahead of the reference datum are negative, and those behind the reference datum are positive. If the reference datum is ahead of the nose, all the arms are positive. So it's actually very handy when the reference datum on an airplane is ahead of the nose. Then it keeps the math very simple. A moment is a force that causes or tries to cause an object to rotate. All right. And that's, we'll get into how to figure out the moment. A moment index is the moment divided by a reduction number, 100 or 1000, to get it smaller to reduce errors. So some people call it a moment index. Some will call it reduction factor. I may interchange the two, but they are one and the same. Center of gravity is the point at which an airplane would balance if it were suspended at that point. So if you could take a string, if you ever had a model airplane or whatever, and try to balance it, wherever that point is on that string, where the airplane stays perfectly level and centered in all planes, that is where you're suspending it from that center of gravity. The center of gravity limits is an extreme forward and aft location within which the plane must be operated. So you'll hear it called an envelope. So your center of gravity may be allowed to be between here and here. And if it gets out of there, you're outside of the envelope and it's not safe to fly. Usable fuel is the fuel available for flight planning. Unusable fuel is the fuel in the tanks that cannot be safely used in flight or drained on the ground. So remember these key terms, you will need them. Basic empty weight is the weight of the standard airplane, optional equipment, unusable fuel, and full operating fluids, including oil. Now, I will say on this, there are a couple of FAA questions where it does not include fuel, all right, or excuse me, oil. So you have to add the oil in there, all right? So there it is noted, but just, quick little sidetrack, just pay very careful on the questions and to see if the oil is included or not. Payload is the weight of all the occupants, cargo, and baggage. The useful load is the difference between takeoff weight or ramp weight, if applicable, and the basic empty weight. All right, that's how much cargo you can hold, fuel, and all of it, okay? Max ramp weight is the max weight approved for ground maneuvers. I know I'm going fast through these, but I don't want this video to be an hour long, so you can always rewind, and you can always just come back and go over these terms again. Max takeoff weight is the max weight approved for the start of the takeoff run. So not when you're rotating, but actual starting that run is your max takeoff weight. Max landing weight is the max weight approved for landing touchdown. Most private pilot type airplanes, general aviation airplanes, don't really have this problem. And there's probably a few out there. I don't know that I've ever flown any that have a max landing weight. The jets we fly, the E-175, it does have a max landing weight. We can be light enough to take off, but too heavy to land. Max zero fuel weight is the maximum weight exclusive of usable fuel. This, again, is also more for the regional airlines, or not just regional, but the airlines. The larger airplanes, your zero fuel weight, that's, and then anything after that, you can pretty much add more fuel to it. Standard weights established for numerous items in weight and balance computations. So these you'll need to remember, put to memory. Gas is 6 pounds. That's probably the most important one for you right now. Is the avgas is 6 pounds per gallon. Jet fuel 7, oil 7.5. But if you're calculating the oil, it's on the written. But still, it's not a bad idea to put these numbers to memory. All right, weight and flight performance. A heavier gross weight will result in a higher takeoff speed, longer takeoff run, reduced rate and angle of climb, lower maximum altitude, shorter range, reduced cruise speed, reduced maneuverability, higher stall speed, higher approach and landing, longer landing roll, and excessive weight on the nose or the tail wheel. Now that's a lot. So we have to be very conscious when we are really heavy. Climbing cruise performance is reduced, which can lead to overheating in climbs, add wear on an engine, and increase fuel use. So just think about a pickup truck or any vehicle, for that matter, just loaded down, all right? Let's just use a dump truck. So you got an empty dump truck and a fully loaded dump truck. Fully loaded dump truck trying to go up a mountain or a hill is going to burn a lot more fuel. The engine's going to get a lot hotter because that engine's working a lot harder. And it's going to burn a lot more fuel. So same thing in airplanes. If you're heavy and you're trying to climb, that engine is going to have to work a lot harder. It's not going to be going as fast. So that means there's not as much air going through the cowling to cool the engine. There's also weight and structures, some of the structural limits. Structural failures caused from overloading may be catastrophic, but they often affect structure progressively, making it difficult to detect or repair. So you'll be like, well, we loaded this airplane all the time to the roof over and over and over again. If you can fit it in there, it can fly. So, you'll hear, but metal, as it gets older, it can weaken. And after landing and takeoff, and after each cycle, eventually that metal can have a breaking point. All right. So the person that airplane fails on may not be the person that overloaded that airplane incorrectly. So it is scary. It's a scary thought, but that's the reality of the situation. So an airplane is certified to withstand certain loads on its structure based on the airplane category. So just keep that in mind, that, when you might get away with it, you might be like, oh yeah, I'm within the center of gravity, I'm a little heavy, but each landing, that airplane's taking a pounding, all right? When gross weight and load factors limits are observed, the total load will remain in limits. So when you adhere to the load factor and the weight, you will protect the structural integrity of that airplane. If max gross weight is exceeded, load factors within the load factor limits can cause damage. So that's not necessarily on the ground on landing. It could be in turns, a steep turn. Anytime you increase that load factor, you can exceed the structural limits of the aircraft. Routine overloading an airplane adds up over time and may result in failure later during normal operations. Weight and stability. A stable and controllable plane may have very different characteristics when overloaded. Weight distribution has the most effect, but gross weight also adversely affects the stability. And you will see either on your oral exam or on your written, maybe both, something along the lines of these airplane with forward loading versus aft loading. So make sure you understand that a airplane with forward loading is heavier, consequently slower than the same airplane with a further aft CG. Nose up trim is required, which requires the tail surface to produce a greater down force, which adds to the wing loading, increasing the total lift required from the wings. All right. So forward loading requires a lot more nose up trim, and therefore puts a greater load on the wings. Okay. It increases the total lift required. It requires a higher angle of attack, which results in more drag and in turn produces a higher stalling speed. The airplane is more controllable. The longer arm from the CG makes the elevator more effective. All right. But it has some cons as well. It does make it more controllable. But if it's too far forward or over its limit, then you may not be able to get the nose up if you get into a nose down situation. All right, so let's look at an airplane with aft loading. All right, aft loading. It requires less downforce, allowing for a faster cruise speed. Faster cruise because of reduced drag, has a smaller angle of attack, less downward deflection of the stabilizer. The tail surface is producing less downward force and relieving the wing of loading and lift. It results in a lower stall speed. Although the stall speed is lower, recovery from a stall becomes progressively more difficult as the CG moves aft. Okay, so if you have a lot of weight in the back in the airplane, the aft of the airplane, that tail gets real heavy. And if you get into a nose-up situation, you get too slow, what have you, you may not be able to get that nose over, okay? And you'll just basically stall the airplane, and that tail is going to hit the ground first, is basically what happens. The CG and the lateral axis. All right. So this is basically keeping your fuel balanced, all right? The CG and the lateral axis. Unbalanced lateral loading, more weight on the right or left side on the aircraft centerline may result in adverse effects. This can be caused by fuel imbalance, people, bags, etc. Compensate for any imbalance with trim if available, or constant control pressure. This puts the aircraft in an out of streamline condition, increasing drag and decreasing efficiency. So anytime you put trim in, you're creating more drag, okay? Weight and controllability. Generally, an airplane becomes less controllable as the CG moves aft. The elevator has a shorter arm and requires greater deflection for the same result. Stall recovery is more difficult because the plane's tendency to pitch down is reduced. If the center of gravity moves beyond the aft limit, stall and spin recovery may become impossible. As the center of gravity moves forward, the airplane becomes more nose heavy. The elevator may no longer be able to hold up the nose, particularly at low airspeeds, takeoff and landing glides. All right, so basically the most critical point of flying. All right, so when you're coming in for a landing and you got a nose low attitude, you try to bring that nose up, you may not be able to. That means prop strike, nose strike, hit the land on the nose wheel, what have you. Weight and balance control. The pilot is responsible for the management of weight and balance. Use the flight manual approved method and charts. Do not exceed the manufacturer's weight and CG ranges. There are various methods to determine weight and balance conditions. There are calculations, there are graphs, and there are tables. Determining weight and balance. Center of gravity equals total moment divided by total weight. All right, begin with the empty weight and make a list of everything that will be loaded in the airplane: people, items, and fuel. Note the weights of everything as well. Your bags, your pilot bag. It's good to measure all that stuff. Make sure the total weight of what you want to load is within the max weight limits. If the total weight is too high, you have to remove items or people to get within the weight limits. Calculate the moment of each item. To find the moment, use the graph or multiply the weight by the arm and the POH. Use the method provided in the aircraft flight manual. The weight divided by moment of the empty airplane are found in its weight and balance documents. Calculate the center of gravity. Total moment divided by total weight. For example, the Diamond 20 compared the total weight and total moment on the graph in Supplement 4. Use the chart in Supplement 4 to determine, okay, we're not going to do that. I have some examples in the other lesson plans. All right, so just do that. Keep it simple. Any weight added causes a positive moment. Any weight that is removed is a negative moment. Weight shifted rearward or aft causes a positive moment change. Weight shifted forward causes a negative moment change. Weight shift changes only the moment. Change in weight equals 0. And there are some examples. So basically, if you're just moving a passenger from the aft to the forward, the weight's staying the same. The only thing that's changing is the moment. All right. Review the conclusion. Weight and balance greatly affects the flight and is therefore very important. We ensure that the airplane is correctly balanced before every flight. All right, you will be doing this for the rest of your career or the rest of the time that you are operating an airplane. Now, if you fly the same airplane every day, endlessly, you'll know the limitations of that airplane. You'll know, hey, I can go, by myself, full fuel, and I'm fine. Now, when you start throwing, filling the airplane up and you have a question, maybe you have a friend that's a little heavier or whatever. I know it's kind of awkward to have to ask a friend how much they weigh, but for the safety of the flight and safety of the airplane and yourselves primarily, sometimes you have to ask those questions. The weight and balance terms, just watch the video again if you need to go over those weight and balance terms again, and make sure you understand the effect of weight and balance on performance and the methods of weight and balance control. And we'll see you on the next video.